VLSos, this is a video lesson on polynomial division by hand. Oh boy. It's best to use technology to do problems like this. A good calculator or software program can probably handle this, but we want to learn how to do this by hand so that the processes behind the calculator and the software are not mysterious, and because it is an excellent practice for organizing and using and applying all of these rules with algebra, number, and exponent properties. So I have a polynomial, and I want to divide it by another polynomial. I have the same problem set up to be done in two different ways. This first is the traditional long division algorithm or format or process. What is being divided is underneath the division bar. What's dividing it is outside, written to the left. And the process will produce an answer that will put above the division bar. The second way that I'm going to do this problem takes advantage of the area model for multiplication. It reverses the process of thinking of a product as the product of the two sides, and the two sides, when multiply, make the product that is then listed term by term in the cells of the rectangle. And then when we add all of those cells of the rectangle, it produces the product that then can be listed down here. We are going to reverse this process because we're going to start with the product and undo it to find the two sides, one of which is known, and then the other will produce by the process at top. And that way we'll understand this divided by this side produces the other side. First, long division. The process that I'm going to go through when viewed for the first time is probably going to come off as fast, hard to follow. So learning this process will probably take two views, once to see what happens, and then a second time to review the steps that were taken. I want to think and start with this leading term of 6x to the fourth, and this leading term of what's dividing it of 3x. And I want to think, what can I multiply 3x by to produce the 6x to the fourth? If I was able to think of what multiplies the 3x to get this term, then I would find the thing that starts with 6x to the fourth is produced after dividing it by 3x. So I'm thinking in reverse. To get to 6, I need to multiply the 3 by 2. And to get to the x to the fourth, I need to multiply x by x to the third. So that's 2x to the third. That's a cubic term, so I'm going to put that cubic term, which is part of my answer, aligned with the cubic term underneath the division bar. The second step then is to multiply, and it should, after multiplying, it should confirm that I get 6x to the fourth because that's what I want to eliminate. 2x to the third times 3x is 6x to the fourth. But I have a second term here of negative 1 I also need to account for. 2x to the third times negative 1 is negative 2x to the third. The third step in this process is then eliminating what I produced from what I was working with by subtraction. The 6x to the fourth minus 6x to the fourth makes 0. So I've eliminated that a leading term of 6x to the fourth, and I can now work with a new leading term. The new leading term is going to be negative 5x cubed minus negative 2x cubed. This can be difficult, so we need to go slow. We have a negative number, and we're subtracting a negative number. So it's a negative that is going to increase. and still be negative. Or in this case, negative 3x cubed. The new leading term is negative 3x cubed. I'm going to repeat this process of 3 steps and eventually work through all of the terms and then eventually produce the final answer. So the first of these steps is to consider, it's a process in 3 steps. First is consider what times 3x makes the negative 3x cubed. It's going to be a negative number, and I'll multiply by 1 because it's 3 in both cases, and an x squared. Second step, multiply the negative x squared times the 3x, and I do get a negative 3x cubed. And the negative x squared times negative 1 is a positive x squared. Third step, I find out the new leading term by subtraction. Negative 3x cubed minus negative 3x cubed is 0. The 10x squared plus x squared nope, 10x squared minus a positive x squared is 9x squared. You just saw me almost make a mistake, but then slow down and think and check, which is a good thing to do quite often in this process. I have my new leading term of 9x squared. I think, what times 3x will be 9x squared? I need a 3 to multiply the 3 to get 9. I need an x to multiply the x to get x squared, and it's positive. 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Turn it into subtraction. 9x squared minus 9x squared is 0. Negative 18x minus negative 3x is negative 15x. What times 3x equals negative 15x? It's got to be negative 5. Negative 5 times 3x is negative 15x. Negative 5 times negative 1 is positive 5. Turns into subtraction. Negative 15x minus negative 15x is 0. 5 minus 5 is 0. I have worked through all of my terms and what I'm dividing. I have eliminated my leading term and reduced it to 0. There is no remainder. This is the answer up top. 2x cubed minus x squared plus 3x minus 5 without remainder. I'm going to do this process again, but organized in a different way, taking advantage of the rectangle model for multiplication. It's still a 3-step process. Whatever is in this box, this square, will be our leading term, 6x to the 4th. Whatever is in these 2 boxes, if I've set it up correctly, will be like terms that when combined make this negative 5x cubed. We collect and add together the terms in the rectangle to produce what we list here. So we're going to reverse this process 1 step at a time. I need to place at the top of this square what, when multiplied by 3x, makes the 6x to the 4th. It's going to be 2x to the 3rd. And the product of 2x to the 3rd and 3x is placed inside this box. The contents of the box is the product of the sides. Now that I have this side of this box labeled, I can find the contents of this box by multiplying the 2x cubed and the negative 1. That makes 2x cubed. The third step in this 3-step process is to determine what is in this box so that when it's added to this, together make the negative 5x cubed. What do I have to add to negative 2x cubed to get negative 5x cubed? I need another negative 3x cubed. The sum of these 2 boxes must be equal to this. Now that I have this box contents labeled, I need to think, what am I going to multiply by the 3x to make the negative 3x cubed? It's going to be an x squared, and it needs to be negative. If I have the contents or the top of this box, I multiply by the negative 1 to get the contents of this box. Negative x squared times negative 1 makes the positive x squared. What do I add to x squared to get 10x squared? I add 9x squared. The sum of these two has to equal this. Now I'm back to the beginning of this three-step process. Step number 1, what do I multiply by? The 3x to get the contents of this box, 9x squared, 3x. Now that I have the side of this box, I can multiply by negative 1 to get the contents of this box. Now that I have the contents of this box, I need to know what I'm going to add to it to produce the negative 18x. That'll be negative 15x. Again, the three-step process. What times 3x equals negative 15x? A negative 5. Negative 5 times negative 1 is a positive 5. Now to finish the third step in the final box, I want to consider, what do I add to 5 to get 5? And I would put outside that amount. In this case, it's 0 because there's no remainder. I produce the answer at top. If this last box was not equal to the last term, then the remainder would be what we would add to it to produce the last term. In this case, there's no remainder. So we have a 0 here. If there were not a remainder, we would need to express the remainder as part of the answer, still being divided by what we're dividing the entire polynomial by. I could show that I have a remainder of 0 by showing it as 0 over 3x minus 1. And of course, the value of this, since its numerator is 0 and doesn't need to be shown in the final answer. But again, if there were a remainder, then you'd express it as that remainder still divided by what we're dividing by, 3x minus 1 in this case. Here as well, I could place the remainder as plus the remainder over what we're dividing by. This is a tedious process, and the chance of making a mistake while you do it is very high. So going slow and checking your answer is important to get them right. After you do it and practice it 1 or 2 times to understand how this works, it's best to use technology if this were a part of another problem.